Hey guys, today I am not able to be with you today because I had to be out for my son getting his braces on. But what we're doing is we're covering Unit 5, Day 3, which is the fundamentals of probability. So make sure you grab a warm-up on the front table if you haven't already, and we will get started. So our warm-up is going over what we learned last class. Here are the formulas that we could use, but also understand that the calculator can just do it all for you. And I taught you guys how to put it in. When I go over this in a minute, I will show you how to put them in the calculator as well. So for number one, let me go ahead and put my document camera up real quick. I'm going to do it on my docu camera instead. So for number one, it's 9 permute 4. So the way we put that into a calculator is you type the 9 first, then go to math and arrow over until you land on probability. It might just be PRB instead of PROB on your calculator, and then go down. Since we're doing permutations, it's that second one down, and then hit enter, and then you type the 4. Now yours might look a little bit different on your calculator. It might say 9 and then NPR and then the 4. It's still doing the same thing. It's just different calculators to show it differently on there. So after you type the 4, then you hit enter, and it tells you 3024. So on my paper, it's 3024. Now we're going to do the first row is all permutations. The bottom row is all combinations. So let's go ahead and do 7 permute 3. So you type 7, then math, over to probability, and then down to permutations. So that's the second one down. Hit enter, and we said it was 7 permute 3. So we type 3 and enter. And we get 210. So on your paper, go ahead and write 210. Number 3 is 10 permute 4. So on your calculator, type in 10, then math, over to probability. And that's what we're going to be using that column a lot for this unit. And then we're going down to permute, so the second one down, hit enter, and then we're doing 4 and enter. So it's 5040. So make sure on your paper you get that answer down, 5040. For number 4, doing 8 permute 5. So 8, math, over to probability, and then down to permute, enter, and then 5. So our answer is 6,720. All right, now we're going to do combinations for our second row. So we're going to do 8 and then 2. So 8, math, over to probability, just like we've been doing with permutations, but this time you're going to go down to the third line for combinations where it says NCR. Hit enter, because that's the one we want to use, and then type in 2 and enter. And we get 28. For the next problem, it's 12 and then 5. So you type in 12, math, over to probability, down to the third line, which is NCR for combinations. Hit enter, and then type 5 and enter. So we get 792. For our third one, it's 10 and then 6. So our n is 10 and r is 6. So you type in 10, math, to the right until you hit probability, and then down for combination. So the third one down, hit enter, and then type 6 and enter. And if I ever go too fast on here, pause the video, catch up. That's the wonderful thing about making videos. So we got 210 on that one. And then our last one is 7 and 3. So type 7 on your calculator. Oh, not the arrow button. That was stupid. Clear that. So 7, math, to the right for probability, and then down for combination. Hit enter, and then 3 is our R. So 3 and then enter. And it calculates the answer to be 35. Now the wonderful thing about calculators is they did all the hard work for you. Remember, you could still go back and do the formulas that were on here that we learned last class. So n factorial over n minus r factorial. So let me show you what that would look like on our paper if you were to figure it out that way. So on this one, it would have been, remember, it always goes n PR. So, and that formula was n factorial over n minus r in parentheses factorial. The combinations one was NCR, and that was, I think it was the same formula, but then we also had an r factorial on the bottom. Let me just double check. Yeah, same formula, and then there's just an additional r factorial on the denominator. So I'll do one of each of those the long way. So that formula was n factorial all over n minus r factorial r factorial. So for the permutations, like this first row, let me give you an example of one. We've got our n is 9, our r is 4. So that would have been 9 factorial all over 9 minus 4 factorial. So that gives me 9 factorial all over 5 factorial. And you can also type it into the calculator that way. But what it actually means, just to show you what the n factorial and then, or the 9 factorial and the 5 factorial means, it means 9 times 5, times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1. And the 5 factorial means 5 times 4 times 3 times 2 times 1. So if you notice, what actually happens is on the numerator and the denominator, we've got 5s that cancel out, 4s that cancel out, 3s that cancel out, 2s cancel out, 1s cancel out. So really, it's just 9 times 8 times 7 times 6. So if you type into a calculator those, you should get the same answer. So 9 times 8 times 7 times 6. Hit enter, and we get that 3024 that we got. The other way I could have done it was, instead of showing you what 9 factorial meant, 9 times 8 times 7 times 6, and then canceling out, is we could actually enter into the calculator the 9 factorial over 5 factorial. And where you can find that is you type 9, and then go to math, over to probability, and then you'll see the factorial button down on number 4. So you could hit enter, and then that's in the numerator, so we're going to hit divide, and then put what we have in the denominator, which is 5, math, over to probability, and then down to the factorial. Hit enter, and then hit enter again, and we get the same answer. Okay? So just so you know, there are multiple ways to do it, but actually using the permutations button is the easiest, the quickest. All right, now to show you a combination example. This is what we did last class. We've got 8 and then combination 2. So our n is 8, our r is 2. So we're using that formula n factorial over n minus r factorial and then r factorial. So n factorial would be 8 factorial, and then over n minus r, so that's 8 minus 2 factorial, and then times r factorial, which is 2 factorial. All right, so to break that down, we've got 8 factorial over 6 factorial, 2 factorial, which ends up being, to see it all wrote out, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 6 times 5 times 4 times 3 times 2 times 1, and then we also have that 2 factorial, so times 2 times 1. So the 6, 5, 4, 3, 2, and 1 all cancel each other out, so what we're left with, 8 times 7 up top, 2 times 1 on the bottom, so that is 56 divided by 2, which gives me 28. So you can see that's what we got for our answer. But to actually type it into a calculator just like this, then since we have 2 factorials on the bottom, after I hit that division button, then I'm going to have to put parentheses around this so that I know that it covers all of that. So I would then hit 8 math over to probability, and then down to the factorial button, enter, divided by parentheses, because we've got 2 on the bottom. We've got 6 factorial and 2 factorial. So 6 math probability. So you can see how cumbersome this is and how much it's not easier to just use the combinations button. Enter, and then 2 factorial. So 2 math probability, and then that factorial button. And then finish it off with parentheses and enter. And we get 28. So that takes a lot more just punching into the calculator. It's just much easier to type the 8 math over to probability for combination. Oops, I went too far. For combinations, go down to the combinations button, which is the third one down, hit enter, and then you got your R, which is 2, and enter. That's so much easier. So we got 28. All right, but I just want to show you, refresh your memory on when we worked it all out the long ways instead of just letting the calculator do it. Alrighty, so you know how to do all those. That was a refresher from last class. Warm-up's done. Now we're going to get into our notes for today. So for today, we are going to learn about the fundamentals of probability. So that includes learning how to compute theoretical probability and empirical probability. And I'll explain the difference once we get into it. All right. So it's not a big notes day, but it's important. I love probability day. All right, let's look at it. So theoretical probability is when you're thinking about, you're not actually physically doing what they're telling you to do. Like you're not actually rolling the dice, for example, 1. You're just saying if a dice is rolled, what's the probability of rolling a certain number? That's theoretical. So it's just like in theory, if I rolled a dice, what are my chances of it landing on a 3? Empirical probability is when you actually do an experiment and then you figure out probability based on that experiment. So first up, theoretical probability. So we're going to talk about if I roll a die, and a die singular, so that's a die singular is just called die. So instead of dice, it's just one die. If we roll a die once, find the probability of the following: rolling a 3, rolling an even number, and rolling a number less than 5. So for the first one, what's the probability of rolling a 3? Now when you're talking about theoretical probability, you want to put in the numerator the number of desired outcomes. So how many 3s are on a die? Well, there's only one 3. So that one would go up top in the numerator. For the denominator, it says what's the total number of possible outcomes? Well, on a die, there's 6 possible sides. It's 1 through 6. So the 6 would go on the bottom. So let's go ahead and write that out in our notes here. So for finding this probability, we want to write the number of 3s on a die would go in the numerator over the number of possible outcomes. I have to find a finer pen. So there's only one 3 on a die, but the possible outcomes on a die are the numbers 1 through 6. So there's 6 possible outcomes. So our probability of rolling a 3 is 1/6. Now the part B, we need to know, well, how it's wanting to know the probability of rolling an even number. So we need to know, well, what's the number of even numbers on a die? Over the number of possibilities. So for the number of even numbers on a die, well, we know that there's 1 through 6 on a die, so the even numbers would be 2, 4, and 6. So there are 3, so I'm going to write that out to the side, 2, 4, and 6. So there's 3 even numbers on a die. And then we know there's 6 possible outcomes, 1 through 6. And then you always want to reduce your fraction. So 3/6 becomes 1/2. So the probability of rolling an even number is 1 out of 2. Now we need to look up or try to figure out what's the probability of rolling a number less than 5. Well, the numbers on a die that are less than 5 are 1, 2, 3, and 4. Do not include 5 because it says less than 5. If they had said less than or equal to, then yeah, you would include 5, but they only said less than. So we've got 4 possibilities for 4 numbers that are less than 5, so 4 desirable outcomes, and then out of the 6 possible outcomes gives me 4/6. So always reduce your fraction. These can both be divided by 2, so that would give me 2/3. And if you struggle with reducing your fractions, let me show you on your calculator how you can do that. So if our fraction is 4 over 6, take 4 divided by 6. Now before you hit enter, hit math, enter, enter. And it'll reduce the fraction for you. So it tells me it's 2/3. So if you struggle with reducing fractions, use that. Type in the fraction and then hit math, enter, enter. All right, back to our notes. All right, so let's figure out what's the probability of rolling a number that's less than 10. Well, all the numbers are less than 10. So that's 1, 2, 3, 4, 5, and 6. So there's 6 numbers less than 10, and there's 6 possible outcomes. So that is 1. Now when you get a 1, that means you will 100% of the time roll a number that's less than 10. That's what it's saying. And then part E says a number greater than 6. Well, there are no numbers greater than 6, so that would be 0 out of the 6 possible outcomes. So that's 0%, or 0 probability. So there's no chance of rolling a number that's greater than 6 because there aren't any on the die. All right. Example 2, you are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a king. So this is where it gets tricky because not everybody plays cards. So not everybody realizes how many kings, how many whatever there are in the deck. I grew up playing cards a lot, so I just always assumed everybody else did and knew all this stuff. So when it comes to us working on things like this in class or taking quizzes and tests, I will have it displayed out on the screen, every card in the deck, nice and ordered for you, so you can see how many there are of everything. All right, so there's always 52 cards in the deck. They want to know what's the probability of being dealt a king. So if you don't know this, there are actually 4 kings in the deck. So how we find this is the number of kings over the number of cards in our deck. So that ends up being 4 over 52, because we told you that there's 52 cards in the deck. And then you just reduce that fraction, and those are both divisible by 4, so that gives us 1/13. So the probability of pulling a king out of the deck is 1 out of 13. The probability of drawing a heart out of the deck. Now, there are 4 suits in a deck of cards. There's diamonds, there's hearts, there's clubs, and then there's spades. So there's 4 suits. So since there are 4 types, there's actually 13 cards of each one of these. So, because 52 divided by 4 gives you 13. So there's 13 diamonds, 13 hearts, 13 clubs, and 13 spades. So the chances of drawing a heart is 13 out of 52, which reduces to 1/4, as it should. You can see that they all have the same amount, so if hearts make up 1 out of 4 out of those, so it's 1/4. Okay. Now they want to know, well, what's the probability of drawing a king of hearts? So for each one of these suits, there's one of each card there. It goes ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. So that's what the 13 cards are for each one of these. So there's only one king of hearts in there. Because out of the 4 kings, there's 1 king of diamonds, 1 king of hearts, 1 king of clubs, 1 king of spades. So there's only 1 king of hearts out of the 52. That fraction doesn't reduce anymore, so that's it. Okay? Again, if I go too fast, just pause the video, rewind, do what you got to do. All right, what are the chances of drawing a red card? Now, there's only 2 colors of cards in the deck. There's black and there's red. Your diamonds and your hearts are red cards. Your clubs and your spades are black cards. So the chance of drawing a red card, well, if there's 13 diamonds and 13 hearts, that's 26 cards out of the 52, which reduces to 1/2. Now, if you already saw that it was going to be 1/2 because 2 of the 4 of these are red, then yeah, you can just put 1/2. You don't have to put all that out there. But I just wanted to show you there are 26 red cards out of the 52, which reduces to 1/2. Pardon me, I need a drink. Part E says, a black ace. What's the probability of drawing a black ace? So there's going to be 4 aces, right? There's 1 of each one of these. 2 of them are black, 2 of them are red. So we know there's 2 black aces out of the 52. Reduce your fraction, and you've got 1/26. So the probability of drawing a black ace is 1 out of 26. And the last one for our theoretical probability is, what's the probability of drawing a 2 of clubs? So just like the king of hearts, there's only 1 2 of clubs, because remember, each one of these suits has 1 number for each one. So it goes 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. So there's only 1 2 of clubs. So that's 1 card out of the 52 cards. So again, 1 out of 52. It doesn't reduce anymore. So the chances of drawing 2 of clubs, 1 out of 52. All right, now as for empirical probability, we have a formula. It says if E is an event that may happen when an experiment is performed. So remember, empirical probability is when an actual experiment is being performed. Then the empirical probability of event E is given by, and this stands for probability of event E, is approximately, that squiggly equal sign means approximately, the number of times the event E occurred. So since we do an actual experiment, we can see how many times that desired outcome occurred, that event occurred, divided by the number of times the experiment was performed. Okay, so like flipping a coin. If we were trying to figure out, well, how many times did it come out, or what's the probability, empirical probability of flipping heads? Let's say we flipped our coin 10 times and 8 out of 10 times it was heads. Then that probability would be 8 out of the 10 times we flipped it. Okay, so that's the difference between empirical versus theoretical. Theoretical, you have a 50-50 chance, so it'd be 1 out of 2. But empirical is when you actually do the experiment and see what that event was compared to how many times we performed that experiment. All right, so example 1, and it may be hard to read these. It definitely is hard to read these. It's better on my original print. I'm going to let me cover this up because it's just really printed poorly on you guys. Let me cover up my answers so you don't see them real quick, and then I'll put you my original table up there so you can see a better version of it. Just bear with me. because it did not copy well. Okay, here's a better version. So if you're struggling to see it, and I can zoom in a little bit too because the numbers are small. Okay, it's a little bit better. So here's an experiment that was done. It says, example 1, the table below shows the distribution by marital status and gender of the 212.5 million Americans ages 18 or older. So, we'll put this below it. Don't mind me. We'll get our stuff together here in a minute. So here's the actual problems it's asking. It says, so they told us that there's, of the 212.5 million Americans ages 18 or older. So this is who they did this experiment with. It says, and you can read the table here, it says marital status of U.S. population ages 18 or older in the millions. So of the men that 18 and older, they did this experiment with, 28.6 million were never married, 62.1% were married, 2.7 widowed, 9 million divorced, with a total, so the total number of men that they questioned was 102.4 million. Of the females, 23.3 million were never married, 62.8 were married, 11.3 were widowed, 12.7 million divorced, and there was a total of 110.1 million that they had asked this question for. All right, so the questions down here says, if one person is randomly selected from this population of that 212.5 million, find the probability to the nearest hundredth that that person, A, is divorced, B, is female, blah, blah, blah. So we'll do the first one first. So remember, when we're doing empirical probability, sorry, tilted my page, we want to put, and go back to the formula, it's going to be the number of times that event occurred that they're asking me about over the number of times the experiment was performed. So if one person is randomly selected from the population, blah, blah. Let's say, so we're looking for, find the probability to the nearest hundredth that the person is divorced. Okay, so we're looking, and we do have totals here too. So they didn't just say men divorced or females divorced, they're saying the total divorced. So the divorced is at 21.7, and again, that's representing millions, but we're just going to stick with that decimal for now. Divided by the total number of people that they asked this question, okay? So they asked this 212.5 million people. So 212.5, and so you use a calculator and divide that out. Let me pull up my calculator. So we got 21.7 divided by 212.5. And we get that big decimal. Now what they asked us to do was round to the nearest hundredth. So here's the tens position, hundredths. So when they say to the hundredths, then you got to look one more number to the right. It's a 2, so that means that 0 stays a 0. So 0.10. Okay. Check, make sure I did that right. Yep, got it. So this is the probability, which is basically 10% of the people had been divorced. Okay. Question B says, what's the probability out of all those people that they were female? So out of the group there, let me pick a different color to do so this isn't too confusing. Here's blue. All right, so out of the females, there is a total number of 110.1 females. Again, that's millions, 110.1 million out of the 212.5. So we just type that into the calculator. So we got 110.1 divided by the 212.5. And we get that decimal. So again, we're rounding to the nearest hundredths. So there's tenths position, there's hundredths. So we look at the next number. Since it's an 8, that means that 1's going to get bumped up. Remember, 5 and above, give it a shove. So it's going to be 0.52. So just over half of the people they asked this question, or asked these questions, were female. All right, never have been married. Let's pick another color. What we got? What we got? So never being married. Now they didn't break it down into men or women. They just said never married. So we want to go with the total. 51.9 divided by our total, 212.5. Let's see what that gives us. So 51.9 divided by 212.5. I get 0.244 tenths, hundredths. The next number over is a 4, so it's this one stays a 4. So 0.24. So of the 18-year-olds and older, because remember, you have to think this is 18-year-olds on up. So most 18-year-olds are not married. So I'm sure a lot of this is the younger group in there, but not all. So that's why it's 24%, or 0.24. All right, and last but not least, what's the probability that who they were talking to was male? So the total number of male out there was 100. Let's pick green. So our total number of men out there was 102.4 divided by the total number, 212.5. Divide that out and see what our probability is. So 102.4 divided by 212.5. We get 0.481. So here's the tenths, hundredths. You look at the next one. That one means that 8 stays the same. So 0.48. Which makes sense because this part B was female, part D is male. So these two add up to give you a whole 1. So 0.42 or 48 and 0.52 add up to give me 1. So that would include everybody then. So that makes sense. All right, so that's how you do those. The homework for tonight is at the bottom of your notes page here. It's 633 to page 634. It's kind of all funky through here. So just kind of pay attention to what numbers you have to do and what you don't. So 1 through 5, 13 through 16, 20 through 24, 28 to 30, 52 to 58. Okay? So do all of those for your homework tonight. That is due next class. If you have any questions, remember my homework key where I have half the problems done is on It's Learning. You can have that open while you're doing your homework. Make sure you're doing these properly. Got your work all shown. And that's it. I will see you guys next class. Get your homework done.